Hi, I'm Rachel.
And I'm Jon.
We're going to walk through serverless application security on Firebase. Specifically, what features come out of the box and what do you as the application developer need to configure or be aware of?
We will outline how you can secure your app end to end.
First, let's address the pineapple in the room and answer the question, what does serverless mean? In a serverless application, there are still servers, but they're managed for you, in this case by Firebase.
Many people speak of services like Firebase Functions as being synonymous with serverless, but it's much more than that. Serverless refers to any design that leverages third-party tooling or services to replace most or all of the application's backend, which would otherwise need to be maintained by the developer.
Here we have components of a simple Firebase app. Cloud Firestore handles the database interactions, Firebase Authentication makes user sign-ins a breeze, and Cloud Functions handles the compute for our backend interactions. For the remainder of the talk, we'll use a hypothetical shopping app that only uses these components.
The app is pretty simple, but we will review some of its key features and user journeys before moving on. First, a user would download and install the app. When they do that, Firebase will associate the specific installation with a unique instance ID, or IID. This IID is a unique identifier that Firebase can use for things like notifications, analytics, and A/B testing. Additionally, our app will be using anonymous authentication, which is similar to a guest account, but more on that later.
When a user adds or removes something to their cart, we write to a document in Firestore. That triggers a function that confirms the items are still in stock and recalculates the total price. The function then writes back to the cart total and any out-of-stock notifications, which can be used by the client apps. This is a simple, minimum viable shopping app.
We'll spend the rest of the talk discussing the security of our proposed shopping app. We'll talk through what security you get by default and what you need to configure as the developer. We'll end the discussion with a checklist that you can use to audit your own app. To help with all this, we've flown in our favorite security researcher.
Hey, hi Jon, hi Rachel. I'm Vincenzo, the Vulnerability Vulture. I was just overhearing you explain this shopping app, and I have some questions.
We thought you might. Let's jump in.
My first concern is that I like to use a client or SDK code that is open source. If I have to include proprietary code, it doesn't have the benefit of having lots of eyes on it that can help spot security problems.
We believe that our SDKs should follow the principle of open design. This is the idea that security should be addressed by correct implementation and review processes, and not by hiding the source code from would-be attackers. Because of this, most of our SDKs are already open source. For the parts that are not yet open source, we are actively exploring how to decouple them from proprietary dependencies so that we can release them to the public as soon as possible.
The SDKs are doing a lot of work to provide an idiomatic and convenient interface, and we recommend using them. If for some reason you can't or you have implementation concerns, you can always fall back and use the REST API directly.
That's really good to hear. I don't want to use code I can't see, you know? The next thing I think about when I look at this app is that I want to protect myself against a malicious actor. What kind of DOS protection do Firebase services like Authentication and Firestore provide? How will my Firebase services handle an attack?
Good question. Let's first explain some terminology to the folks at home. DOS, or DOS, stands for denial of service. The traffic from a DOS attack is meant to flood a system or application with so many requests that it can't respond to requests from real users. This is bad. If our users can't shop, we can't make money with our app. Since traffic goes up as a result of denial of service attacks, your bill could also go up. If you suspect an attack on your application, reach out to support as soon as possible and let them know what's happening. However, Firebase does offer some protection against this scenario. If your service has request spikes, often quotas will kick in and automatically throttle traffic to your application. This throttling protects both your application as well as other applications being hosted on shared infrastructure.
Wow, Jon, this is great information. But what about Firebase Functions? What specific denial of service protections are offered there?
Great question. Functions handle this kind of traffic differently because they're built to auto-scale to the limits that you set. If you set a max of 10 concurrent functions, for example, a malicious actor couldn't run up your bill too high. They could probably deny service to your legitimate users, though, because functions wouldn't scale to service those real users. When you're getting used to functions, almost everyone DOSes themselves if they don't try out their functions locally before they deploy them. For example, the function in our app listens to the items subcollection of the cart, but suppose I set up the listener to listen to the cart itself. An item could be added to the cart, and then the function would run, which would write back to the cart. That would trigger the function to run, and that would write back to the cart, and so on.
If this happens to you, remove the function and redeploy once you have fixed the issue. Depending on the magnitude of the mistake, you may still want to reach out to the support team to let them know what has happened. To mitigate the risk of DOSing yourself, use the Firebase Emulator Suite to test the flow of your app locally before you deploy your functions.
That's great advice. Returning to malicious actors, if you're really being DDoSed, traffic will generally trigger an API level restriction that will block a lot of the traffic before it's added to the quota for your app. The structure of your functions can also be defensive. For example, say I have an app that lets users hit a +1 button to like something. Instead of triggering my +1 function every time a user likes something, I could write those to a pub sub queue and have my function run periodically to consume and roll up those triggers that have taken place, and now they'll happen in one read-write operation. This reduces the real-timeness of my app, so I don't want to use it for everything, but it's an option I want to have in my back pocket if I'm worried about abusive traffic.
Wow, that's great information. Now let's talk about Firebase API keys. With other API keys, I'm very protective of them. I keep them in environment variables or a vault specifically made for secrets, so I never expose them in the code. But with Firebase API keys, I don't just put the keys in the code, I put them in the client code, where anyone could see them. Is this safe? Does this let a malicious actor make requests as if they're my app?
Many services use API keys as both a user identifier and as a key, so it's very important not to share them. That's fortunately not how API keys work in Firebase. The Firebase API key only lets us know which Firebase application the client should be making a request to. It's made to be included in the client and does not need to be kept secret. Access control to your data and storage depends entirely on the security rules you've configured for those services, not whether or not you have an API key. Additionally, you can set up API key scoping. This ensures that your API key can only be used when paired with your app's specific headers. This helps provide a bit more defense in depth by creating more obstacles for an attacker who is attempting to spoof requests.
I should also mention here that your API key is different from your server key, which is used with services like Firebase Cloud Messaging. This key is meant to be kept secret and should not be confused with your Firebase API key. So let's update our checklist with some of these action items.
Wow, this is really good to know. Let's talk about security rules. I know that security rules are the configuration I can write to set access controls for my database or storage buckets. Are there any real consequences if I don't do that?
If you're using Cloud Firestore, Firebase Storage, or real-time database, you should always pay attention to your security rules. Default Firebase storage rules allow access to all of your stored objects by default. Preferably, change your rules to deny all access until access is needed. Real-time database and Cloud Firestore both offer default rule options. We highly recommend that you create your databases in locked or production modes respectively in order to leverage the principle of having fail-safe defaults. These modes mean that by default, no access will be granted. You can then adjust your rule sets to allow only the access that is needed as it is needed. These security rules are what will prevent malicious actors from having access to your entire database, so allow access sparingly.
Aha! A malicious actor could read out all your data, back it up somewhere, and then delete it from your database. This is called a ransomware attack, right? Attackers in this scenario usually then ask for payment in order to return your own data back to you.
Exactly. Don't leave yourself open to that. Always configure your security rules.
Okay. How should I go about writing my rules? How do I know if I've done it correctly?
Great questions. Some people leave writing their security rules until the end, after they've written the rest of their app, but that can make it more difficult. Think about security rules as a kind of schema for your application. It's a record of who can access the different kinds of documents in your database, and potentially data validations for the fields as well. Writing rules as you add features is the best way to go. When you make changes to start writing to a new kind of document, also write the rules for who should be able to access that document.
When writing your rules, keep in mind the principle of least privilege. That is, don't allow access that isn't required for your app to function. Read and write are broad permissions. Instead of write access, you could granularly specify create, update, or delete permissions. Instead of full read access, you could specify single document permissions.
Setting read-write if auth is not equal to null at the root of your rules is not an adequate rule, especially if you're using anonymous authentication. Remember that an anonymous auth, a UID, is created for anyone who starts using your application, so this check will be true for all users, and letting them read or write to anywhere in your database is dangerous. As for knowing if you've done enough, we recommend using the Firestore emulator to write unit tests for your security rules. Test that your rules allow the access that you want and disallow the access that you don't want. We've just released a new code lab on local first development that walks through test driving your security rules. And check out the talk by our colleague Yu Chen about setting up CI to use those tests. Links for all of that are in the talk description. So we have a few more items for our checklist.
Wow, thanks. This may sound like a funny question. Do I need to write rules for my functions?
Not funny at all. Functions take actions similar to the client code, but the difference between them is that functions run from a trusted environment, whereas client requests are executed from an untrusted environment. Because of this, we do not need to set security rules on functions. If you are integrating with an existing server full system, you have the option of setting up your own server to communicate with the Firebase backend directly. If you choose to use this tactic, we recommend that you use the Firebase admin SDK. The biggest difference between the admin SDK and the other Firebase SDKs is that requests from the admin SDK are implicitly trusted, meaning that requests bypass your security rules entirely and are always granted access to your data. This allows you to deploy very strict rules while still maintaining access to your data.
Cool, thanks, Jon. Okay, we've taken some steps to guard against malicious users. I also worry about how I'm authenticating my users. If I have app security without user security, it's like I built a big fence around my nest, but I left the key out for anyone to use. Let's talk about user security in Firebase.
Firebase Authentication is Firebase's product for managing users. Authentication is the backend, and we have the Authentication SDK and UI libraries that can streamline development on the front end. A lot is ready to go out of the box, but you still want to be thoughtful about how you're using Firebase Auth. The best practice is to either use managed auth using an OAuth 2 provider or custom auth if you have an existing way of signing in users. Our OAuth options use a variant of PXE, the industry standard. For custom auth, you'll make your own JSON Web Token, or JOT for short, and then you'll do a one-time exchange for a Firebase JOT to get those users into Firebase Auth. Firebase JOTs are short-lived, but they can't be revoked. If you accidentally issue one to somebody, they'll have about an hour of access. Issue JOTs from a trusted environment that you control, not from client code. Our colleague Kevin recently published an example of how to do this using Okta as the identity provider. And check out the talk from Sam and Malcolm that will go into more detail about custom authentication.
If you are starting a new app, we recommend using one of the managed auth options. Not all the options have the same level of security, but sign-in providers that use OAuth 2, like Google Sign-in or Sign-in with Apple, are currently the most secure. If you use email and password sign-in option, it's important to have your users verify their email addresses. If you don't, you are open to account creation abuse. This can make for a terrible experience for your users. Additionally, set quota limits for user sign-in attempts. This will prevent attackers from trying to brute force account passwords. This limit can be set in the Google Cloud Console. Real users can always use the forgot password flow if they truly can't remember their password. I should also briefly mention multi-factor authentication. There's currently not a free option for multi-factor authentication provided by Firebase. However, upgrading to Google Cloud Identity Platform lets you enable SMS as a second factor. It's a bit more expensive, but may be worth it for you. So let's update our checklist.
Wow, this is all great to know. You mentioned this app is using anonymous authentication, but the words anonymous and authentication seem contradictory. What is the use case?
Anonymous auth is our version of guest accounts, and the most common case is for a warm onboarding. You can start saving user information before the user creates an account. Anonymous auth is basically improved session data. Data persists through opening and closing the app, but if a user loses their phone or clears local storage, there's no way to reestablish the link between that user and the user ID that you have in your database. So convert users to a sign-in method other than anonymous authentication before you save data that they'll want back when they lose their phone. Anonymous authentication also comes with risks. Anyone can create an anonymous user on your app, so write your security rules with that in mind. You could use security rules to gate certain documents to only be accessible for users that have an increased level of security. For example, the first rule here only allows access if the user is not using anonymous auth. The second one is an example of only allowing access if the user has verified their email. So we have some authentication items to add to our security list.
Awesome. Thanks so much for clearing up authentication. I've heard that some of the most effective hacks have been accomplished by hacking the account of company employee. How do I limit my team's access to information and functionality?
This brings up another secure design principle: separation of privilege. People should only have access to sections and instances of your app where they need access, and only a very limited number of people should be granted global permissions. This way, one compromised employee cannot result in full access for an attacker. Many employees can develop locally, purely within the emulator suite or within a dev instance of your app. Limit these employees to local access. A staging version of your app is often the next layer of isolation within a deployment pipeline. Using this strategy, we can set up a flow of development from dev to staging to production, while isolating the access to each layer. For those that do need production access, be sure to use granular Firebase permissions or create custom IAM rules for further isolation. To be clear, security rules should be the same across all environments, but your production data is almost always the highest value target.
Wow, thanks. That really helps. I've also heard of some hacks of well-known libraries that started doing mischievous things. What should I do to protect my users in case there's a hack of one of my open source libraries?
You're right to be concerned about open source libraries when they have a new and perhaps less trustworthy maintainer. Also watch out for libraries that are published as a slight misspelling of a popular module. In one instance, a new maintainer of a popular NPM module started to steal Bitcoin. This problem is hard to be alerted to if you're running code on your own machine, and it's even harder if it's running in a function. So what can you do about it? First, there are some libraries that alert you to vulnerabilities in your code. One of those is linked in the description. You can install it as a test or a development dependency, and you can make sure that you don't have a vulnerability like this before you deploy your functions. One of the worst case scenarios is a cloud function that starts doing something very compute intensive in the background. And the good news is that this can't really happen. When your function returns, the CPU for the function is throttled down to 0. So any compute that someone would be trying to do on your dime would only work for as long as your actual function is working.
That being said, it's still always a good idea to set up monitoring on your functions. Firebase Functions is directly integrated with cloud logging, which lets you monitor the invocations, runtimes, and memory usage of your functions over time. You can even configure alerts on specific thresholds.
Wow, that's great to hear. Firebase Functions have a lot of configuration that I can set. How do I know what the right quotas are? If my function is complex, I don't want to set too low of a timeout. For other functions, I'm worried about how to handle sensitive information.
Let's start with how to handle sensitive information in functions. In a server full app, you would normally put the most sensitive information into environment variables, but that's not how it works in functions. You should never put sensitive information into environment variables. The best option for most cases of sensitive data is to encrypt that data. But if you have an extreme case, you have the option of putting the function into a virtual private cloud, or VPC for short. And you can set up a VPC connector that still lets your function be triggered by outside services like your client apps. To figure out what the right configuration options are for your new function, monitor the function's performance to get a sense of what's normal for compute time. Setting up alerts for when you're getting close to your quotas will also give you a heads up if you're starting to go viral and you want to raise your quota, or if something's going very wrong. Check out the new video by our colleague Todd called How to Turn on Billing and Still Sleep at Night. Links to that and to the documentation are below in the description.
Creating simple functions can help mitigate some of the risk here. Complexity in your functions can often lead to hard-to-spot bugs or result in unexpected behavior. Just remember, simple is almost always better.
Good point, Jon. We'll finish the checklist with these final items about function security. To wrap up, security is definitely different in serverless architectures, but Firebase is bringing you the tools that you need to create secure serverless applications. This is a priority for us, and we're building new security features all the time. If you have an app that you need to audit, or if you're starting a new app, use our checklist to make sure that you're doing your part to keep your Firebase app secure. The checklist, along with all of the references that we made in the talk, are linked in the description below.
Woohoo! I can't wait to finish my roadkill delivery app. A free possum with every order. Thanks for all the information.
No. Thank you, Vincenzo.